Many thanks to all of you for coming out today, and last but not least, many thanks to the translators who are doing excellent work so far. So today I wanted to talk about accountability and ethics, particularly one particular possible way of holding those who create AI systems accountable for the things that they create. So, accountability is something that most of us, I think, can agree on. It's something that everyone considers important, but the problem is we have yet to really settle on a uniform way to hold AI accountable. One of the reasons why that is because there are so many questions left unanswered. There we go. Actually, all of the questions remain unanswered. What I call the who, what, when, where, and why. In my own teaching, I teach private law, particularly the law of torts, civil causes of action for remedies for wrong, and I hear the word accountability often. Particularly, one of the questions that I keep asking myself over and over is accountability for what? What sorts of actions do we want to hold makers of AI accountable for? I realized that I didn't have the appropriate body of knowledge to answer that question, so I teamed up with a group of roboticists and authored 2 papers where we came up with one possible approach to hold those who make AI accountable. We call it an education theory of fault for autonomous systems. In my talk, I'd like to make 3 simple points. 1, the impreciseness of human language and mental models can create misunderstandings and gaps in the development of AI. 2, when people work together to build autonomous systems, they should try to reduce that impreciseness and better structure specifications to technology. 3, within fault-based systems like tort law, we could conceptualize this as a duty for procurers of AI, designers of AI, and users of AI to test and educate each other on what is desired, what is possible, and what to watch out for. Point number 1, it's hard to talk about and understand automated systems in precise ways. The reason why is actually relatively simple. The reason is that human language is imprecise. We tend to employ words like safety and security and bias, but those words are all capable of multiple meanings. The other reason why is that complex systems are unpredictable. And when you combine the impreciseness of human language, which we use in AI systems, at least to help mold AI systems, with the complexity of AI systems, we get something like this. This actually happens in South Korea, where an automated vacuum cleaner happened to suck up a woman's hair who was sleeping on the floor. The vacuum cleaner did not sense the hair as an obstacle and thus proceeded onward. If we dig into this, we see that creating an automated system involves translating imprecise human language into very precise data from sensors, to be collected from sensors. The problem is that people have background knowledge to draw upon, but unless programmed, automated systems have no background knowledge to pull from. So for example, when humans recognize and categorize objects, this is a red ball, they not only rely on the colors that they see, but on the vast store of semantic knowledge about which they might be looking at. So shirts, for example, are approximately the size of a human torso, so we recognize them. They are often appear wrapped around people. They are made of cloth, which reflects light in a very particular kind of way. They have a typical shape. The cloth is typically not rigid. Apples, on the other hand, are small, round, and often found on trees. The problem with object recognition and classification on a robotic system, or an AI-driven system, is that in order to be reliable as a human, in order to make the same kinds of mistakes, and in order to be predictable, people would have to encode all of the prior knowledge that humans have about the world. This is simply impossible. And what we're left with then are these unpredictable systems that rely upon the impreciseness of human language. Now, I don't mean to say that we should make autonomous systems predictable. In many cases, actually, the unpredictability is precisely what we want out of automated systems. But we can work to be more specific as possible about what we want AI to do, what risks are foreseeable in the development of an AI system. Think of it as working to reduce the unforced errors in the AI building process. And by doing so, we might be able to make them safer and more trustworthy by holding them accountable. That leads me to point number 2. Teams developing automated systems should be responsible for testing and keeping each other informed. When I refer to teams, I mean procurers, those that procure the automated system, designers or developers, those who create the automated system, and users, end users, ultimately those who end up using the automated system. And what my colleagues and I are arguing is that we should aim to reduce the kinds of failures that commonly happen in the creation with procurers working with designers who then pass on products along with users. And there are 4 types of common failures that we've identified that we could aim to reduce, that we could obligate, in fact, people to try and reduce in the process. The first kind of failure is what we call a syntactic failure. Syntactic failures occur when developers fail to communicate to procurers the many different ways in which robotic systems might fail to identify real-world objects. This error occurs because of a mismatch between the precision of artificial sensors and the robustness of human senses. Consider a robot trying to find red balls. First, we must define what we mean by the word red. Most humans with normal vision have an intuitive understanding of what red is, that it comes in many shades, that pink is sort of kind of red, and that blue is not red. However, for a robot, we must define a closed set of pixel values in the red, green, and blue channels that most digital cameras use. We have to delineate the idea of red. A color that is just outside of this narrowly prescribed set is not red, in the same way that blue is not red to these AI systems. If we get the boundary set wrong, then we will detect red objects not as red, and vice versa. Since robots decide what to do on the basis of sensor readings, these syntactic errors can easily cause a robotic system to fail. If asked to identify all people in red shirts, the robot might instead end up finding all people in white shirts that are standing under a red light, or people-shaped objects draped in red cloth, and not a person in a red shirt standing under a blue light. While developers might not be able to eliminate these problems, they can lessen these problems with well-defined sets of tests, which in computer science would be called unit tests. Another kind of failure we call semantic failures. Semantic failures occur when human articulated goals and intentions for autonomous systems are not translated correctly into software. These are failures that fail to accurately translate human intent. They generally will be the result of talking loose, perhaps in colloquial terms, loaded with nuance, with bias, and with a wealth of background knowledge about how the world works. And trying to translate them into concrete numbers can be very difficult. Consider the example of a building security robot tasked with patrolling a warehouse, approaching and questioning anyone it sees after hours. This is a Nightscope security robot. While this is a clear instruction for users, i.e. walk up to someone, ask them, anyone you see, ask them a few questions, there are a lot of implicit assumptions built into the direction that we might give automated systems. For example, if the person sees a robot through the window walking down the street outside, the robot should probably not leave the building. We assume that as people, but we have to tell that to robots. Once it questions a person and determines that they are not allowed to be in the building, the robot should probably not question them a second time if they meet them again. When the robot approaches a person, how close should the robot come before it stops? Humans will naturally pick a socially and culturally appropriate stance, but we have to be very specific when articulating these instructions for automated systems. It is inevitable that semantic failures will happen when we try to translate human terms into robot-controlled software, however much we try to minimize them. However, as with syntactic errors, we can address them with testing protocols. The third kind of failure is testing failure. Testing failures occur when a necessary syntactic or semantic element is simply missing from the test set. This can be the developer's fault. It could also be the fault of the procurer for not fully articulating the use cases. Testing failures can occur when semantic or syntactic tests are not conducted appropriately or are otherwise invalid. Failure to test can lead to this sort of thing, which is when the Nightscope security robot accidentally drove itself into the water in a mall. The final kind of failure that we see in the AI development process is a warning failure. Warning failures occur when end users of a product, are not made appropriately aware of the avoidable problems caused by the unpredictability of systems. These sorts of failures are widely recognized in product liability law in the United States and around the world as a warning failure to be balanced with design defects. A very good example is the levels of automation in a car. I have friends, in fact my own parents, when I tell them about automated cars, they're ready to go out and buy a Tesla and then never touch the steering wheel again. But of course, that's not how Teslas work. We're not there yet at the appropriate level of automation. And so users need to be warned over and over again, not just once. Warnings, we hypothesize, are different than transparency, or even possibly explainability, because transparency and explainability have passive features, right? So we can be transparent, or we can have an explanation that users have to go out and find, or go out and understand. Warnings, however, are about being more forthright, revealing the things that you might rather not as a developer of AI systems, but need to do so in order to keep people from making safe decisions. And if warnings don't work, then they work with these other failures where we say, go back and test again until you make a safer product. All right, and so where does this head? In the end, we suggest that perhaps there is a duty on behalf of developers. Perhaps there is a duty on behalf of designers. Perhaps there is even a duty on behalf of users to educate, not just themselves, but other people. Required education, required testing. First, we should have required testing, both low-level and high-level testing, as well as required education. Required to educate themselves before releasing an automated product, and educating others in the way in which a product foreseeably is going to work and the missing pieces of the system. If we do recognize this as a way of keeping those who develop systems accountable, then it might result in more predictable systems. It might result in more accurate expectation. And importantly, for law professors like myself, it could be a way to allocate who has to pay when multiple parties are involved in the development of an automated system and something goes wrong. In other words, we can look and say, did you take the right steps to educate the other users within the system? And so to do this, we recommend a series of rules, which are in the slide deck. I won't read them here. But we do think that if this is one way, we don't think this is the only way to hold AI developers accountable and procurers, but we think this is a way, and it could have some important implications. We think that it could affect civil law, which are these sorts of disputes are likely to arise as automated systems go out into the real world. They can help shape design rules. We could decide whether there's a standard set process, perhaps an educational process within the development of systems. One of the things that we'll hear about later today is the right of explanation. This could be a way to effectuate some kind of right of explanation, or a way to interpret that right. And finally, it could be important for due process, not just giving notice to people about the way in which an autonomous system works, but warning them about the way in which an autonomous system works, which I think is a substantive difference. And with that, I appreciate your time. Thank you very much.